Hi, I'm Max Williams. I'm an ambassador for the College of Engineering. I am a senior in aerospace engineering, and I am currently here with. I forgot. I'm so sorry. I'm so sorry. Max Williams. I'm an ambassador for the College of Engineering. I'm currently a senior in aerospace engineering, and I'm here with Dr. Nelson. You want to tell us a little bit about yourself?
Yeah, I'm Dr. George Nelson. I'm a associate professor in mechanical and aerospace engineering. I do research in electrochemical energy, so batteries, fuel cells, and heterogeneous materials, that type of stuff. So
Very cool. I'm going to start with the easy question first. Do you prefer coffee or tea?
I prefer coffee. I worked at a coffee shop during undergrad for a few years, and that kind of you know got me locked in on coffee. Not that I don't appreciate tea. I like tea, but
Black coffee or
yeah,
cream and
black
sugar?
coffee.
Black coffee. Everyone seems to be into black coffee. I don't know why. Um, what classes are you currently teaching slash have you taught on campus?
So currently, this semester, I am teaching design of thermal systems. So I actually have two sections of that I teach. Um, I usually teach heat transfer, design of thermal systems, and thermodynamics one, and then at the graduate level, I teach an electrochemical energy conversion and storage class.
Very cool. What's your favorite class to teach?
I don't know that I necessarily would say I have a favorite. They each are interesting in their own ways.
Okay.
I like the slower pace of design of thermal systems in Thermo 1. There's just more time to cover the material. Heat transfer is kind of a flat out run the entire semester because you have to cover conduction, convection, and radiation. So I enjoy teaching them all, uh, but they each also have their own, I guess, unique challenges that come with them.
You mentioned research. Are you involved in industry or anything else outside? And can you tell us a little bit more about your research?
Yeah, so my group does work on batteries and different power systems. So we have research projects on lithium ion batteries, sodium ion batteries, and alkaline batteries. We do X-ray and neutron imaging of those batteries. So the X-rays allow you to see kind of heavier elements. So in a lithium ion battery, for example, you have nickel, manganese, and cobalt oxides that are used on the cathode side. So we map out those materials and see how they change using the X-rays. We can look at them at micron scales or down to hundreds of nanometer scale, and understand how the materials are changing structurally, chemically, how the geometry of the materials affects the behavior of the battery. And then with the neutrons, you can see lithium, and so we're using that technique, developing it to basically observe the movement of lithium in the battery and how the structure of the battery influences it.
You just said a lot of words that I don't know.
That's
I heard neutrons, though. I knew that one.
Well, it's
Uh,
kind of like a medical X-ray, but if you did it with neutrons, it would kill you.
oh, okay. That's very exciting. Um, what qualities do your most successful students typically have?
I think the most important quality is work ethic. At some point, especially when you get into engineering research, you're going to be working on problems that you haven't worked on before, you haven't solved before, and so nobody solved them. So um, they're, you know, really what you need is just kind of, constant work and tenacity to kind of work through the problems and figure them out. And so that's kind of what makes the difference to, that I see.
Okay, very good, thank you. Um, do you have any hobbies or anything you like to do outside of your research and teaching here?
I run and swim for exercise. I cook. That's something that I kind of developed in graduate school, especially. I get home and have like a break at the end of the day to make dinner, and then I could go back to doing a little bit of extra work after that. Um, so it was one of those things where I had to eat so I could take time to do that. Yeah. So I actually integrate that a lot with my heat transfer class, which is dangerous if I have like a 4 o'clock class because everybody's hungry, and I'm sitting there talking about how semi-infinite slab behavior is like cooking a steak or something like that, and you know
Making me hungry right now.
it's about lunchtime.
Yeah. Um, if you were to rank the different types of engineering, who would you put first and who would you put last?
Well, obviously I put mechanical engineering first. I don't know about last. I'd have to think about that one.
We can give you a second to ponder if you'd like.
What programs do we not have here?
Well, we don't have
I have to
biomedical.
be political on that,
Yeah. We don't have optics. We have a whole optics
right?
building.
I mean, it kind of goes into the comment about the comment I made about my classes. It's hard to say like which one's unnecessary. It's kind of what is it that you're looking to do with your career, and where do you want to go with it? Where do you want to take it? Is kind of you know they all have their place, I guess. Is kind of what I would say.
So that was
I wouldn't necessarily put one last.
that was a really good way to avoid my question.
It was. For
But
me,
I'm-
last. So the entertaining part about that is, I started out as a mechanical engineering student, and I initially thought, well, maybe I'll go into, maybe I'll try chemical engineering instead. But then I didn't really like my chemistry class right off the bat, so I was like, all right, maybe not chemical engineering. And then, as I went further on, like electromagnetism and circuits, like they didn't quite do it for me class wise. And then, years later, here I am doing electrochemistry research. So it's kind of not what you wouldn't expect. So you put something last, and then suddenly it surfaces later. And.
Yeah. Do you have any opportunities for students to get involved in your research?
Yeah, so I bring students on at the undergrad level through, I've done that through RCEU, so Research and Creative Experiences for undergraduates, through experiences for undergraduates on like some of the NSF projects I have. We can get additional funding to basically bring on undergraduate researchers, and then usually every project that I write a proposal for when I get funded, I write in hours for undergraduate students as well. So I have opportunities in my lab, whether it's modeling and simulation work, or doing work in the lab that we get undergrads involved. Right now, I have one of the projects I didn't talk about. We're looking at, we're doing kind of top level thermodynamic analysis of power systems for lunar applications. And so I have a couple undergraduates that are helping with that, and I have students that had brought along as undergrads, and then they did the jump program and continued working with me as graduate students who just graduated in with that work on that project. So
That's awesome. Do you have any advice for students coming to college and trying to decide trying to decide if engineering is right for them in the first place, and then what discipline of engineering that they should go into?
I would say you want to seek out different experiences in those fields if you can. You know, you quite often find what you want to do by doing what you don't want to do, and it takes some time to figure out what areas you're really passionate about. Like when I started out in mechanical engineering, I thought that I would be doing more structural work or something of that nature. But I was, I guess, less compelled by my statics class. I was more interested in my thermodynamics class. I really enjoyed my fluid mechanics class, and that's kind of what got me into going into the thermal fluid areas. So it's those places that you don't necessarily expect to see it. I did co-op work, which was really helpful because I got to rotate through different parts of a company and see what it was like in industry to some extent, like what it was like to do that day to day as an engineer. So I got to see manufacturing engineering, controls, some project engineering. So I got a lot of exposure on that. So getting experiences, trying internships, trying undergrad research. It's really just explore a lot of those different experiences and see what you can get. That's my number one piece of advice on it.
Any advice for students coming into college in general?
I think that to me that applies
Okay.
in general as well. You want to take the opportunity to be a student. You're not always afforded the flexibility that you get when you're in college. So you take advantage of that opportunity while you can, especially when it comes down to like learning details of different, engineering systems or different problems. You really get to explore things in a lot more depth. That when you get out working, it's more, you got to get to the results as fast as possible, and you don't get as much free exploration time. So take advantage of that.
That was good advice. So the last thing I think we're gonna do is we saw this cool little gadget you got sitting over here, and I think we're gonna let you show us how it works.
So this is a fire piston. So I use it in my thermodynamics class to show the concept of internal energy. So the idea here is you've got a piston in a cylinder. It's actually inside of this. It's a double-walled cylinder. So you've got the outside glass and an inside glass, and if you push down on the piston hard enough, you elevate the temperature, and the internal energy, and that goes up and ignites a small piece of paper. So I'm going to see if I need to put a fresh piece of paper in this first. So grab my handy repurposed paper clip. And hopefully that will ignite better. This one's been a little charred. So. Grab a small piece of this paper towel. So the idea here is that you're putting, if you think about this from a thermal one standpoint, the basic energy balance, you're putting work into this system, and you don't have kinetic or potential energy changes. So there's got to be some kind of change in the energy. So let me move a couple of these things very quick. I'm making it hard to use a videographer.
I feel like I'm shooting your office. I get close-ups.
So let's see if we can get this thing to go on the first try. Sometimes it takes a few tries. So you can see that there is smoke that was forming there. So there we go. I think we got it one time, but you can see how it ignites, right? You get the internal energy up high enough. So I do this in my thermo class as one means of showing that idea. So it's a nice little piece of equipment for that.
That was awesome. Are we gonna see you at E-Week?
I am planning to come by for I have the showcase on my calendar.
Awesome. Well, we appreciate your time, and hopefully
Yeah.
we'll see you there.
Excellent.
Thank you.
I forgot that I was doing the interview. Like I had looked at my calendar when I ran out this morning, and I looked at it and I was like, "Wait a minute, should I have worn something nicer?" But I'm like, "All right,
Nah.
nice t-shirt and
They're like
jeans,
super
like a
casual.
Friday day."
Well, I didn't think I was going today, so that's okay. All right, I'm gonna be so happy to be here right now.